Hi, this is Arash and welcome to Epoxy channel. In this channel, we're going to talk about the epoxies from the theoretical aspects to the most practical ones. So if this is the first video that you're watching, or if you're interested in epoxies, please like and subscribe to our channel for more videos. Today, I'm going to present health and safety of epoxy resins. Unmodified epoxy resins are stable and are not generally harmful. Two-component epoxy products contain an epoxy part and a curing agent, which are packed separately. These components must be mixed together just before the application. In the one-component product, the resin and curing agent are premixed. As the hazardous chemicals are already combined in these systems, their time of exposure is less and they are generally safer. In modified epoxy systems and formulations, other components such as modifiers, reactive diluents, fillers, catalysts, etc. are also incorporated in the system. In this system, the hazard associated to individual components should be communicated by the manufacturer and considered by the user. These risks are prominently displayed on the Material Safety Data Sheet SDS, which must be available at the workplace. Here the toxicity of unmodified resins, modified epoxies and formulations, system with solvent, diluent, modifiers, fillers, accelerator, etc. Cured epoxies and also the curing agents will be discussed separately. Let's look at the unmodified epoxy resins first. The unmodified liquid epoxy resins are relatively mild irritants to skin, eyes, and mucous membranes and are capable of causing skin sensitization. Overexposure to these resins may result in hypersensitivity, ranging from dermatitis to chronic eczema. Dermatitis is divided to acute contact dermatitis and allergic dermatitis. Acute contact dermatitis is also a common type and develop in less than 10% of people working with epoxy resins systems. Allergic dermatitis, also called sensitization, is the most serious type, which develop in almost 2% of epoxy users where body hyperreacts. The irritation potential is increased by the sticky nature of liquid resins. Solid epoxy resins, such as powder, preforms, or film, are even less toxic because they have a very low vapor pressure. However, they still can present a hazard when they are heated to cure. The main effect of overexposure to these resins are irritation of the eyes, nose, throat, and skin allergic and asthma. However, their acute oral toxicity is low. Mild vapor inhalation of most liquid resins is not a hazard unless the resins are heated or the epoxy have a very high vapor pressure. Solid epoxy resins are considered to be low to mild sensitizers. They are not readily absorbed through the skin and present a low risk of skin irritation. However, fine powders of epoxies should be considered as an irritant dust, and the inhalation in skin contact should be avoided. Susceptibility to skin irritation and sensitization depends on the individual's tolerance. Skin allergy might be developed after just a few days of exposure or after many years of contact, depending on the individual. No evidence supports the effect of unmodified epoxy resins on pregnancy and reproduction in humans. Modified epoxy resins contain diluent and plasticizer or other modifiers and comparably constitute a larger risk of skin irritation and sensitization. The toxicity of a formulated product is determined based on hazard of the most toxic ingredient. The manufacturer of the formulated product has to provide information about the components in the mixture and the toxicological information in the SDS documents. An SES must present the hazardous chemical content and provide guidelines for the handling, safe use, storage, disposal, as well as the health and safety hazards. Reactive diluents are generally impose a high degree of hazard and are capable of causing skin and eye irritation. Due to their high vapor pressure, they may present a significant hazard from inhalation. Compared to epoxies, these materials vaporize more readily and have an increased potential for inhalation exposure. Moreover, diluents are likely to be much stronger sensitizers than the epoxy resins. Reactive diluents with significant volatilities and lower molecular weights are more hazardous to the skin, eye, and respiratory tract. The inhalation of this system is a hazard under certain conditions of use, such as heating, spraying, or applications with large surface areas. Overexposure to solvents and other high vapor pressure material of the modified epoxy can cause headaches, nausea, dizziness, confusions, and loss of consciousness. Solvents commonly used in epoxy resins application present flammability and other special hazards. Finally, some diluents in solvents may affect reproduction. Ethoxyethanol and methoxyethanol are solvents found in epoxy formulations and are suspected to result in birth defects. Contact with solvent is also enhances the chance of skin irritation, and it can be absorbed directly through the skin. There is also the risk of dissolving other chemicals and carry them through the skin. The inhalation of solvent vapors or mist may cause respiratory irritation and a depression of the central nervous system. Fillers used in the epoxy resin formulation vary in their degree of hazard from handling. Some fillers are more hazardous than the others, and some affect certain tissues of the body, whereas others considered to be essentially non-hazardous. Initially, they are potential inhalation and thermal contact hazards, especially when they are handled in the dry form or during machining or grinding of the cured epoxies. However, when they are handled in a liquid epoxy matrix in a cured epoxy, the risk is low. Certain inert fillers such as glass fiber, if handled improperly, may be abrasive to skin. This results in skin irritation with symptoms such as redness, swellness, flaking, and itching. Dust of glass silica bearing powders and powdered metals may present a serious hazard from inhalation or explosion, mainly because of their high surface areas. Occupational inhalation of some fillers, for example fiberglass and crystalline silica, result in delayed lung injury. That's why asbesto fillers have been abandoned from the use. Fully cured epoxy products are practically non-toxic, non-irritant, and non-ferrous. However, in the process of machining, grinding, cutting, or sawing of the cured surfaces, hazards may arise from the produced dust, fumes, and the generated heat. Fumes and dust can be handled appropriately by employing a proper ventilation. It should be noted that the cured resin exposed to severe heats, the decomposition products of the cured resins may exhibit substantial vapor pressure and pose health and safety issues. Curing agents are generally more hazardous than the base epoxy resins, and specific information on these materials should be requested from the manufacturer. The aliphatic and cycloaliphatic amines, as well as anhydride curing agents, may be skin sensitizer and cause irritation or damage to the skin, eyes, and lungs. Aliphatic amines are strong irritants and potent sensitizers. They are alkaline caustic materials which can cause severe tissue damage, and even in dilute solution form, they can still cause severe eye damage or by splashing. The aromatic amines are not as caustic and irritating as aliphatic amines, but they are a skin sensitizer. They may absorb through the skin and cause damage to organs, result in hematolysis, liver damage, osteomyelitis, etc., and interfere with the blood's ability to carry oxygen, and some others, for example DDM, are suspected to be carcinogen. Solid anhydride curing agents may cause sensitization. Among curing agents, polyamide type curing agents are considered to present a lower degree of health hazard. Although they are eye irritants, they are advantageous with respect to their low skin irritation and sensitization. Exposure to curing agents may develop asthma with symptoms such as chest tightness, shortness of breath, wheezing, and coughing. Finally, once a person becomes allergic to epoxy, future contact will generally always cause a reaction and should be avoided. Here the safety measure for safe epoxy handling is presented. These measures must be considered to mitigate the potential risk and hazard associated with epoxy formulations. There are personal measures that have to be considered before using epoxies. These personal measures include individual sensitivity, how one's body can tolerate epoxy chemical, as well as individual aptitude, user knowledge about epoxy systems and their applications. Initially, employees must be informed about the associated hazards and be instructed to avoid careless handling of epoxy formulation, as exposure may lead to skin sensitization. Furthermore, allergic employees should be prohibited from working with epoxy formulations. Proper ventilation with exhaust system has to be considered for mixing operations. Wear safety gloves and glasses is mandatory when handling epoxy systems. If a skin contact happens, the contaminated clothes must be changed immediately, and any residue of resin left on the skin should be removed with soap and water or with special cleaners, but not solvents. If the epoxy resin compositions, for example grease, adhesives, coatings, floorings, etc., are supposed to be applied outdoors, for example on building site, it is often harder to consider precautions. And it is particularly important that operators are properly informed of handling precautions and procedures. In terms of fire accident, the STS document can be referred to. However, epoxy resins and curing agents fire can be extinguished with carbon dioxide, foam, or dry powder, and water is not an effective extinguishing agent for them. Moreover, toxic byproducts such as ammonia, aldehyde, and carbon monoxide gas can be released during the burning of these components, and organic vapor, respirator, or self-contained breathing apparatus are mandatory for firefighters. The waste of epoxy systems can be handled by trained workers, either by controlled burning in an adequate incinerator or by burial in an approved landfill. Equipment and machinery need to process epoxy systems can be hazardous. A special care must be devoted to mixing equipment, for example, because of risk of splash, and curing equipment, fire or explosion hazard is there. Thermal exposure is the most likely route of exposure, which is most probable in task involving hand contact with the epoxies. There are some strategies and policies to limit the exposure of operators to epoxy systems and ensure the protection over epoxy system, which are often of the employer's responsibility. In general, the strategies to limit to prevent potential exposure to hazard chemical are training, substitution, engineering control, protective equipment and clothing, and good housekeeping. Conducting training programs for all involved personnel who might be in contact with epoxies is a need. Continued instruction must be given concerning the handling, precautions, and consequence of contact, particularly labels, safety data sheets, health and safety hazards, emergency procedures, and first aid, personal protective equipment, and safe handling procedures should be trained. There are also technical epoxy-related topics that have to be explained and trained to the operator in advance. For example, flammability and instability, risk of different solvents, the risk of curing exotherms, etc. By substitution, the intention is to use a safer chemical if one is available. Substitution is effective, but also a difficult task as it is directly affects the performance, applications, and end-use properties, and also requires that the complete product be re-verified with production and prototype testing. Concerning epoxy formulations, resins with higher molecular weight, or the ones that contain little or no free epichlorohydrin, as well as employing curing agents that are less irritating than the simpler aliphatic amines, for example, polyamides or amidoamines, are safer. Employing safer solvents and diluents or developing waterborne and UV EB cured epoxy resins to eliminate solvent is another strategy to make epoxy formulation safer. The aim of engineering control practices is to reduce the amount of potential risk by modifying process or equipment. For example, isolation, ventilation, maintenance, policing, and changing the work practices are of the methods of control. To minimize the hazards and health risk, the use of epoxy resins can be isolated to design separate areas in the plant. For example, spray booths and enclosed curing and mixing rooms, etc. A good ventilation is also necessary to control exposure to airborne vapor of epoxy resins and solvents. The most common type of personal protective equipment or PPE include eye protection, gloves, aprons, and respirators. Safety glasses with side shields, chemical goggles, full face respirations, and face shields with glasses or goggles can be used for eye protection. To protect the hands from repeated contact with epoxy materials, cotton, leather, or rubber gloves should be worn. Both physical and chemical resistance characteristics of gloves must be considered. Physical characteristics include wet grip, cuts and tear, puncture and abrasion resistance, and chemical resistance is required to resist permeation and degradation, where the gloves should endure the aggressive of the resins, solvents, and other material. Ethyl vinyl alcohol laminates and butyl rubber gloves provide excellent resistance to epoxy system, whereas neoprene and nitrile gloves has less resistance to solvent and certain epoxy curing agents. Protective clothing, for example aprons, coveralls, lab coats, etc. should also be made of materials suitable for epoxy systems or chemicals used in associated processing. Air-supplied respirator with an external supply of clean breathing air or air-purifying respirators, which uses absorbents and fillers to purify air, might be required based on the process and involved chemicals, especially when solvents or dust level are high or when irritating other and sensitizers are present. To minimize exposure level to human chemicals, considering personal hygiene is also important. The improper handling of contaminated clothing is crucial. The storage, laundering, and disposal of contaminated clothing should be provisioned. First aid guidelines have to be presented in STS documents. First aid kits in facilities must be maintained in a nearby isolated area. Skin or clothing contamination with epoxy component is the most common situation. In these circumstances, first the contaminated clothing must be removed and the exposed area has to be washed with soap and water for at least 15 minutes. If irritation or other complications develop, medical attention is necessary. The other plausible situation is the epoxy resins or contamination. In such a circumstance, eye should be washed out with eye wash facilities with the clean water, and medical advice should be sought immediately. In the case of respiratory distress, the individual has to be immediately removed from the contaminated area to fresh air. Artificial respiration should be provided if the person is not able to breathe, and medical attention should be sought immediately. The ingestion of epoxy resins and attributed chemicals is not very probable. However, if this happens, seek immediate medical attention and also refer to the SDS documents the ingestion hazards. Emergency procedures often explain flammability, spill contamination, and cleanup guidelines. Flashpoint temperature is a common measure of flammability, which indicates the minimum temperature at which flammable conditions are produced and should be avoided. Regarding the spills of epoxy resins, they should be cleaned up immediately while a spark-producing equipment is kept away. In the spill cleanup procedure, the engaged people should be aware of proper disposal techniques and also should be protected from vapors and skin contact. Absorbent material or high surface area materials such as sand can be employed to clean up small spills of epoxy resin liquid or solution, and the residues should be cleaned up hot soaps, water, or steam. For larger spills, the evacuation and the spill area might be necessary. Due to the hazardous nature of the solvents, the use of solvents during cleanup should be avoided. Epoxy resins must be prevented from entering sewers or drains, and if this happens, local authorization should be notified immediately. In disposing of epoxy resins, several factors have to be considered. If the need is to dispose of the epoxy leftovers or leftovers of the mixed epoxy resins and hardener, first the liquid has to be cured. It is not recommended to dispose of liquid systems of epoxy and hardener. The leftover liquid is better to be transferred into an empty can and left for initial cure in a well-ventilated area, far from the combustibles. After curing, the inert cold solid product can be disposed of based on the regulations. Another issue with the disposal of empty resins and the hardeners containers. Generally, the epoxy and hardener containers have to be emptied as much as possible, and the leftovers should be less than 3% of the total initial mass at the time of disposal. Thanks for your attention. I hope you enjoyed the video. Please share your thoughts, comments, or questions, and I will see you soon.